This video goes over how to find the basic characteristics of a parabola. For each of the two parabolas below, we're going to identify the vertex, identify the axis of symmetry, identify the y-intercept, figure out if it has a minimum or a maximum, state the minimum or maximum value, and then determine the coordinates of two other points on the parabola. So the first thing that we want to do to identify the vertex is to change it into vertex form by completing the square. So for this one here, I'm going to factor out 3 from the first two terms. Then I'm going to identify my b term, divide by 2, and square it, just to complete that perfect square, or figure out my missing value that I need to complete the perfect square. Then I'm going to add and subtract that value. Next, I'm going to factor the perfect square, multiply my last term by whatever I factored out originally, which is going to give me my vertex form of the parabola. So minus 10. Okay, so now I can start stating some of the things that I'm looking for. So the first one, got an extra x squared there. My first one that I'm looking for is the vertex. So my vertex is minus 3 and minus 10. My axis of symmetry is just my x coordinate of the vertex. And to find my y-intercept, I'm going to set x equal to 0. So y equals 3 times 0 plus 3 squared minus 10. So in this case, I would get 9 times 3 is 27. 27 minus 10 would be 17. So my y-intercept is 0, 17. My next one is a min or a max. Because my a value is greater than 0, I'm going to have a minimum value because my parabola opens up like this. Now I'm looking to state the maximum or minimum value and the value of x when it occurs. This is the vertex. So my minimum value is equal to minus 10, just my y value of the vertex, and it occurs at minus 3, my x value of the vertex, and I should say x minus 3 here. The last one is determine the coordinates of two other points on the parabola. So here you can substitute in whatever you would like. I'm going to look at x equals 1 and at x equals minus 1, because those are easy numbers to substitute in. So y equals 3 times 1 plus 3 squared minus 10. Y would equal 3 times 16, which would be 48, minus 10 would be 38, so that would be one of my points, 138. And then I'm going to substitute in minus 1, so I've got minus 1 plus 3 squared minus 10. And then I've got y equals 3 times 2 squared, which is 4. So 3 times 4 is 12, minus 10 is 2. So that would be another point on my parabola, minus 1, 2. Let's take a look at another example. So again, I'm asked to find the vertex, and I have the parabola in standard form. That means that I need to change it into vertex form so that I can easily identify the information. So the first thing that I'm going to do is factor out negative 2 from both terms. And then I'm going to look for the value to put in to create the perfect square. So I'm going to identify my b value, and then I'm going to divide by 2 and square it, which is going to give me 16. And then I'm going to write that in so that I'm able to complete the perfect square. So plus 16 minus 16 minus 27. My next step is to factor my perfect square x minus 4 all squared. That accounts for the first three terms. And then I'm going to take out my last term by multiplying by whatever I factored out at the beginning, in this case minus 2. So then I'm going to get plus 32 minus 27, which means that my final equation is minus 2 x minus 4 squared plus 32 minus 27, which is going to be plus 5 here. Gives me my parabola in vertex form. So then I'm going to identify the characteristics. The first one is my vertex, which is 4, 5. My axis of symmetry is just the x-coordinate of the vertex. My y-intercept, I'm going to set x equal to 0. So I get y equals minus 2 times 0 minus 4 squared plus 5. And then I get y equals, so minus 4 squared is 16. 6 times minus 2 is minus 32. Plus 5 would be minus 27. So my y-intercept is 0 minus 27. In this case, my a value is less than 0, so I'm going to have a maximum value because my parabola opens down. My minimum value is just my y-coordinate of the vertex, and that occurs at my x-coordinate of the vertex. The last thing that I'm going to look for is two other points on the parabola. So I'm going to use x equals 1 and x equals minus 1. So if I substitute in x equals 1, I would get my y-coordinate to be minus 3 squared is 9, minus 18 plus 5 would be minus 13. So I would have 1 minus 13 as another point on the parabola. And then substituting in minus 1, I would end up with minus 2 times 25, so minus 50, plus 5 would be minus 45, would give me another point as minus 1 minus 45. The next example that we're going to do in this video is an application question. So leading into our maximum and minimum problems for our next lesson. In this one, a baseball player hits a fly ball, and the height in meters of the ball is given by h equals minus 5t squared plus 20t plus 1.2. We're asked to determine the maximum height of the ball. Anytime you're asked to find the maximum or minimum, you should always think about looking for the vertex of the parabola. In this case, our equation is given to us in standard form, so we're going to have to change it into vertex form first. So in order to do that, I'm going to complete the square, which means I have to factor out my a term from the first two terms of my equation. Then I'm going to identify my b term, and then divide by 2 and square it, which is going to allow me to write in the numbers to complete my perfect square. So plus 4 minus 4. My next step is going to be to factor those first three terms as a perfect square. So t squared minus 2 all squared. And I'm going to take that minus 5 and multiply it by my last term, and then add my original 1.2 from the equation, which is going to give me my final equation in vertex form. Got an extra t squared, and then I should have 21.2. So now I'm asked to determine the maximum height of the ball. That would be the y-coordinate of my vertex, which I can see from my equation is 21.2 meters. Now my next question is, if it's caught at the same height at which it was hit, how long is it in the air? So the same height at which it was hit, the ball is going to be hit at t minus 0. So let's figure out what that height is. So let's see, minus 5 times 4 would be minus 20 plus 21.2, which is going to give us 1.2 meters that it was hit. Now, in a parabola, there's always going to be two values that give you the same height or the same y value. So what we can do here is actually substitute in our h value as 1.2, and we're going to solve for t. And now what we're going to find is that you're actually going to get two different answers. One of them we know is going to be the time when it was hit, t equals 0. And the other one is going to end up being the time where it is caught. So let's take a look at that. So we're going to bring 21.2 over the equal sign. So we're going to end up with minus 20 equals minus 5t minus 2 squared. I'm then going to divide both sides by minus 5, which is going to give me 4 equals t minus 2 all squared. Now at this point is where I'm going to get two answers. I'm going to take the square root of both sides, and this is going to either give me positive or negative 2 equals t minus 2. So now I've got two cases to solve for. I've got positive 2 equals t minus 2, and I've got negative 2 equals t minus 2. Now on the left side, this one would tell me that t is equal to 4. And on the right hand side, this would tell me that t is equal to 0. So t equals 0, I know, is where the ball was hit. That means that my other answer here must be when the ball was caught. Therefore, the ball has been in the air for 4 seconds.